Okay, so we're looking at example 14 and 15, and we want to write a standard form polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So in number 14, we have x equals plus or minus square root of 5. Those are two real zeros, and their factors would be x plus square root of 5, x minus square root of 5. Okay, that's a conjugate pair. And then x equals plus or minus 2i. I, if you recall, is the imaginary number. It's equivalent to the square root of -1. So when we would look at this graph, the zeros at positive and negative root 5 we would see as x-intercepts, but this plus or minus 2i, these are imaginary, so they would not show up as x-intercepts on the graph. But they do impact the equation, and so we have a factor here of x plus 2i, and then another factor of x minus 2i. Okay, so this is a degree 4 polynomial. And then we've got a difference of squares here with the x plus square root of 5, x minus square root of 5. So we can use our difference of squares shortcut on that set of binomials. And then x plus 2i, x minus 2i, that's also a difference of perfect squares. So when I expand these, I'll have to square the first term, so x squared minus, because it's a difference of squares, and then the square root of 5 times the square root of 5 is 5. Okay, then same thing for this difference of squares, so x times x is x squared, and then 2i times 2i is 4i squared, so that would be an x, let's do that up here, so x squared minus, and then 2i times 2i is 4i squared. But remember, I squared is -1, right? Because I equals the square root of -1. That's what imaginary number means. And when I square both sides of that equation, the square and the square root would cancel and leave me with just a -1. So that would be x squared minus 4 times -1, and then a negative and a negative is a positive, so that's x squared plus 4. So this difference of squares, x plus 2i times the quantity x minus 2i, is x squared plus 4. Okay, now I'm going to FOIL to combine these two binomials. So x squared times x squared is x to the 4th. Then I have x squared times a positive 4, which is plus 4x squared. Then -5 times x squared, -5x squared, and -5 times positive 4 is a -20. Okay, and to be in standard form, we must have decreasing exponents and combine all of our like terms. So in the middle here, we have a 4x squared minus 5x squared. Those quadratic terms can be combined. So y equals x to the 4th minus x squared minus 20, and that would be my polynomial in standard form. Okay, so let's try number 15 now. And 15, we have multiplicity of 3 on this x equals 0. So that factor would be x, and then it's going to be to the 3rd power because that's a triple root. Okay, then x equals plus or minus root 5i. We'll have factors of x plus square root of 5 times I, and x minus the square root of 5 times I. So now we can evaluate this difference of squares, and that's going to give us an x squared, and then the square root of 5 times the square root of 5 is 5. I times I is I squared, which, remember, we did that up here in the corner. We saw that gives us a plus then in the middle, and then the 5. Okay, so now when I go to combine these, I have a monomial times a binomial, so I'll go ahead and distribute. X cubed times x squared is x to the 5th, because when you multiply the same bases, you add the exponents, and then x cubed times 5 is a plus 5x cubed, and now our polynomial is in standard form.